Hello, this is Math 1120 coming to you from the College of DuPage, and the title of this lecture is Statistical Analysis of the Baseball Pythagorean Theorem, Linear Correlation Studies, and this is the third in our series of low-stakes assessment. So you are provided some data, and this is data from the Major League Baseball season 2017. And this file is in Blackboard, and it is attached to an email I'm going to send as well. So here we have a file. These are team names. These are leagues, National and American League. These are the games they played. This is how many they won. This is how many they lost. And this is their won-loss percentage. That is the wins divided by total number of games. This is the streak, and you see they didn't have any streak information here. They could win or lose so many in a row. But this is the average number of runs that each of these teams scored per game. And this is the runs allowed average for each of these teams. You're going to use this data to answer some questions. And the questions have to do with correlations like we saw in our technical videos. And there is a reference that talks about the Pythagorean Theorem of baseball, but I decided to just talk about what it is here. And the idea is that Bill James, who was a pioneer in sabermetrics, applying statistics to baseball, suggested that there's something that kind of looks like the Pythagorean Theorem that it represents very closely winning percentage. And so he said that the winning percentage should be approximately the runs scored squared in the numerator, and the denominator it is parentheses, and this is the sum of the runs scored squared plus the runs allowed squared. And runs scored was runs in the previous chart. Don't worry about these more accurate things. We're going to be using this one in the problem. So here are some specific questions I'm asking you. You should work on these and find some answers. And then you'll go to Blackboard and upload this work and the answers to Blackboard. Now do this work first to answer the questions. So I ask you to construct a histogram showing average runs scored by the major league teams. I ask about how is it skewed or is it symmetric. I ask you to construct a side-by-side box plot showing the average runs scored by the American League teams versus the National League teams. Does there seem to be a difference between the two leagues? And explain your answer. Consider the winning percentages and the runs scored first. Winning percentages and runs scored. And then we consider the pair of winning percentages and runs allowed. What are these correlations? Which of these two has a stronger correlation based on this data? Then you consider the winning percentages and the Bill James original baseball Pythagorean theorem estimate with the exponent equal to 2. What is the correlation here? And is this a stronger correlation than the others? A team is considered lucky if it wins a higher percentage of its games than the Bill James estimate, and unlucky if it wins fewer. Were the White Sox unlucky or lucky that year? Were the Cubs lucky or unlucky that year? Of all the major league teams, which was the luckiest? Now in the video and VCM lecture tonight on 9/8, we're learning that we must be careful about correlation implying causation. What do you think about this situation, the Bill James baseball situation, or in fact all of these? Do these correlations somehow imply causation? So, take-home protocols apply. Do all of the work completely first. Then go to Blackboard Assessments and do the answers and upload them as instructed. Now here we're not only practicing doing statistical work, we're practicing processes, because this is how we're going to do the high stakes assessment, and I want you to have some low stakes experience in doing this. And there will be a password. It'll again be Force Be With You. In the PDF upload section, the graphs that I'm asking for will be uploaded. This is going to be due 1 week from tonight at 11:30 p.m. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now, more than ever, take care of yourself and of each other. God bless you all.